So last class we studied about we started nomenclature and we studied what you can say the history, so to say. In nomenclature we studied basically, and we ended there the difference between the organic and inorganic compounds. Why do we require a separate branch of chemistry called organic chemistry? All these things we studied. Now today we are going to study that when we are studying organic chemistry. Alright, when you are studying organic chemistry, I said you the definition has changed, and today we are knowing this particular branch of chemistry as hydrocarbons. Alright, so why we are having such a large number of compounds? Alright, what is the existence, what is the reason for the existence of such a large number of organic compounds? I said you there are more than 5 millions of organic compounds there. What is the reason? Why we are having such a large number of organic compounds? Alright, so I am coming to it one by one. So the first is, that is nothing but is your catenation. Last class I have explained you about catenation. Again I repeat, catenation is a unique property of the carbon atom to combine with itself and also with other elements to form a large number of compounds. It can combine with itself and also with other elements. So you can see why it forms a large. My question is, remember that, why organic chemistry is having such a large number of compounds. What is the reason for the existence of such a large number of compounds? That is the answer I am giving to you. Alright, so here you can see it can combine with any number of carbon atoms, any number of carbon atoms, because carbon-carbon bond is a very strong bond for that particular purpose. So what I said to you, it's a unique property of the carbon atom to combine with itself and also with other elements, like suppose OH, like suppose Cl, like suppose NO2, in this way. It will combine with itself and also with other elements also. Alright, like suppose in the chain also it may combine, like here also we can get oxygen. We can also get it in this way. So this phenomena or this peculiar property is called as catenation. Due to catenation, you find that we are having a large number of organic compounds. This is one of the reasons. Alright, now the second reason is that presence of multiple bonds. Multiple bonds. Like you will be studying about, when you study hydrocarbons in details, you will be studying. We are having carbon-carbon single bond. We are having carbon-carbon double bond. Alright. Of course it is 3 bonds, 3 more bonds. Why? Because carbon is tetravalent in nature. You must be doing this. So we are having carbon-carbon double bond. We are having carbon-carbon triple bond also. We are having it. This is carbon-carbon's single bond. You can say single bond. So you can see single bond. Here carbon-carbon double bond. Here carbon-carbon triple bonds. In this way, it can form multiple bonds. These two are known as multiple bonds. These two bonds, double bond and triple bond. You will be studying. This is known as alkanes. This group of compounds is known as alkanes, where we are having not 2 carbon, any number of carbon. Just I am writing here 2 to explain an example. Here this sort of compound are called as alkenes. Now here N means N-A-N-E means carbon-carbon single bond. Alright, that is alkane. Alkane means we are having single bond. When we say E-N-E, that is alkenes, means it is carbon-carbon double bond. Similarly, if I say A-L-K-Y-N-E-S, alkynes, Y-N-E, it is known as what? Triple bond. Alright, so in this way, that is, it can form multiple bonds. This sort of phenomena, this sort of peculiarity, you don't find in any other elements. Alright, you don't find in any other compounds, in any other branch of chemistry, we can say that, except in organic chemistry, we can say that. So it can form multiple bonds. Easily it can form multiple bonds. Alright, easily it can form. And remember that here what I have done is that you can see carbon is having 4 bonds. See here, this carbon 1, 2, 3, 4. This carbon 1, 2, 3, 4. This carbon also same thing. It is having 4 bonds. Alright, why? Because electronic configuration of carbon, if you write it, is 2, 4. So it requires 4 more electrons. It requires 4 more electrons to attain the octet structure. So once it attains the octet structure, it becomes what? Stable. So 4 more electrons means same thing. 1 pair of electron is nothing but what? 1 bond. This is 1 electron, this is 1 electron. So 1 electron comes from this carbon, another electron comes from this carbon. So it forms 1 bond. Count it, the number of electrons also. 1, 2, 3, 4, 5, 6, 7, 8. This carbon also 1, 2, 3, 4, 5, 6, 7, 8. Otherwise it's very simple. Each carbon is having how many bonds? Maximum 4 bonds it can have. So 4 bond means how many electrons? 4 into 2 to 8 electrons, because each bond consists of 2 electrons. A pair of electron it consists of. Very easy to understand. because its outermost shell is having 4 electrons. You must be knowing this, you have studied this. Its outermost shell is having 4 electrons. It requires 4 more electrons to become stable. For that purpose, it is tetravalent carbon is. The maximum, what you can say, the valency of carbon atom is 4, we can say that. So it can combine with 4 other electrons. So hence its maximum bond is the 4 bonds. You will be studying it. Alright? Achha. So this is one reason, that is multiple bonds, we can say. The next reason is that very important, it shows isomerism. Organic compound shows isomerism. Organic compound shows catenation. Organic compound shows multiple bond. Organic compound shows isomerism. Isomerism, you know, it's a property by which a compound shows different structural formula but the same molecular formula. Alright, when 2 or more compounds, they have got the same molecular formula, listen carefully, when 2 or more compounds have got the same molecular formula but different structural formula, due to the different methods of preparation, is known as what? Isomers, and the phenomena is known as isomerism. So you can see it here, the last class I have said you that some examples I have given you in the last class. Now here some more examples we can give. We can have so many other examples. Alright. Like suppose we are having C3H6O. C3H6O. Now C3H6O can be written in this way also. Like you see here. That is, I can write it here as CH3, CH2, CHO. I can write it. I can write it also as CH3, CO, CH3. I can write it as. Alright, now count it here. Hydrogen 3 to 5, 1, 6. Carbon 1, 2, 3. And oxygen is 1. See here? Here also carbon 3, hydrogen 6, oxygen 1. Still one more compound also we can have it. Still one more compound. Alright, what is that? Let me write it here then. One more compound we can have, or here also I am having the space. CH2 double bond CH, single bond CH2OH. Alright, see here, CH2 double bond CH, single bond CH2OH. Here it is carbon 3, hydrogen 213 to 516, oxygen is 1. Alright. So this compound is called as propanal aldehyde, functional group CHO. Propanal, we can say that. This compound is called as acetone or propanone or propantuone, we can say that. Acetone, this compound is ketone, the functional group is ketone. Here this compound is called as allyl alcohol. This is known as, this compound is called as allyl alcohol. This is because this group is called as allyl, and OH is the functional group. OH means what? Alcohol. So this is your allyl group. How it comes allyl? Everything I'll say you. Slowly and slowly you'll come to know. Have patience. Alright. So in this way, what you find is that we are having the same molecular formula but different structural formula. This is an aldehyde, this is a ketone, this is an unsaturated alcohol. Unsaturated why? Because double bond is there. And alcohol means OH. Alright. Saturated. This is called saturated. Carbon-carbon single bond is saturated, but double bond and triple bond is called as unsaturated. Unsaturated means still we can add it to it. Yes. Alright. We can break up the double bond and make it single bond. We can break up the triple bond and make it single bond. Double to single, we can make it. That is called unsaturated. Alright. You have read it in chemistry, unsaturated solution. So unsaturated solution means what? It can dissolve more of the solute at a given temperature. That's called. So it can also break. The bonds can break and it can, some more atoms can be added here. Like it can dissolve more of the solute. Here also same thing. If you think in the same way, in the same light, then what is that? Why did I say unsaturated? These two. Because what I said, double bond can be broken down to single bond. Here triple bond can be broken to double, double to single. That means how can we break it? Here this will bring it here. That means we'll add some more atoms. Here also same thing. These 3 bonds we can break it and we can bring it here, 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 here. We can bring it. So that's it. So in this way, what you can find is that when double bond gets broken to single bond, when triple bond gets broken to double bond, double to single, you can say that. So these compounds are called as unsaturated because we can add some more atoms to it. But can we add it here? In case of alkenes, no, it's already saturated. How? Because each carbon is having 4 bonds. You will say, sir, here also it is 4. Yes, 4. But it can be broken down. But here, can it be break it down? This one. If you break down, then it's altogether it forms a different compound. It is not alkenes. Here also same thing. It forms a different compounds. Alright. Clear? So more of it you will be studying in the, what you can say, in the next chapter you will be studying when you will study hydrocarbons. Then I will be going in more and more of details and your concept will be clear in that case. So in this way what you find is that this compound, this molecular formula shows isomers. In this time many what you can say isomers are there, we can say that. So the three reasons for the formation of, or for the existence of a large number of organic compounds is that it shows catenation, it shows multiple bonds, and it shows isomerism. These are the unique features you can find only in carbon or the compounds of carbon, that is in case of organic chemistry. For that reason there are a large number of organic compounds which is being known to us, we can say that. Thank you very much.